Welcome to your deep dive listener. Ready to blast off? We're exploring the awesome intersection of math and astronomy.
And I do mean intersection. The articles you sent really highlight how essential math is to understanding the universe.
It's mind-blowing, really. We always picture those astronomers with their telescopes.
Right.
But turns out, behind the scenes, it's all about equations and calculations.
Absolutely. I mean, what we call classical astronomy, that was all about direct observation. But these days, math gives us the power to go way beyond, what we can actually see with our own eyes.
So no more just stargazing. We're like decoding the universe with math now.
Exactly.
Speaking of decoding, how about the discovery of Neptune? That's a classic example, right? Really shows how powerful math can be.
Yeah, Neptune, that's a great example. Astronomers weren't just looking around and stumbled across it. They actually noticed something was off with Uranus's orbit.
Something was off.
Yeah, it wasn't quite lining up with Newton's laws. And remember, those laws, they come from calculus, which is all about motion and forces.
Okay, so they suspected something was messing with Uranus, like gravitationally.
Exactly. They used those discrepancies in the orbit, plugged them into Newton's laws, and predicted where a planet should be to cause that gravitational pull.
A cosmic detective story. So then they pointed their telescopes to that spot.
And there it was. Neptune, right where the math said it would be.
Incredible. Okay, so we're talking about some complex stuff, but I'm curious about simpler math, stuff we use every day. How does that fit into astronomy? What about like trigonometry? I remember using that to find the height of a tree or something.
You laugh, but trigonometry is a perfect example, and it's got deep roots in astronomy. Think about those ancient astronomers trying to chart the stars and planets. They needed a way to, describe their location in the sky.
And that's where triangles and angles come in?
Precisely. They'd measure the angles between a star, the Earth, and then use a baseline, like the distance across Earth's orbit. Then, boom, trigonometry to calculate distances, even to those super far off stars. And we still use the same principle today.
Get out. So SOHCAH from high school is helping us map the universe.
That's right. And it's not just about distances either. Remember conic sections, ellipses, parabolas, hyperbolas, all that from algebra?
Oh, yeah.
Well, those aren't just shapes on a graph. They're the actual paths that planets take, including our own Earth, around the sun.
Wait, so those elliptical orbits are more than just like stretched out circles. That shapes actually mean something?
It's everything. The shape of the orbit, it dictates how fast a planet's moving at different points, and that's where we get Kepler's laws.
Kepler's laws. Break that down for me.
Okay, so Kepler's laws, they explain planetary motion, right? But they're fundamentally based on the geometry of ellipses. So a planet speeds up when it's closer to the sun. We call that perihelion.
Okay.
And it slows down when it's farther away at a point called aphelion.
So the math is literally controlling the planet's speed.
Precisely. And that impacts tons of things, from seasons here on Earth to whether a planet in some far-off solar system could even support life.
It's crazy how a mathematical concept can govern the way planets move.
It is amazing.
So we've gone from triangles to ellipses, but I feel like we're about to go even deeper into the math-cosmos connection.
Oh, you have no idea.
Okay, so triangles, ellipses, pretty cool stuff, but I have a feeling things are about to get even more cosmically mathematical, right?
You got it. We've talked about Kepler's laws, the how planets move. Now we're getting to the why, and that's where calculus comes in.
Calculus, like derivatives and integrals, that calculus.
Yep, that's the one. And it wasn't invented to torture students, I promise. Calculus revolutionized how we understand gravity, the whole shebang of celestial mechanics. See, before calculus, we could see the planets moving, but we couldn't really grasp the forces behind it all.
So calculus was the missing piece of the puzzle.
Exactly. It allowed Isaac Newton to come up with his law of universal gravitation. It's this beautiful equation telling us that everything in the universe, it attracts every other thing. The force depends on their mass and how far apart they are.
It's what keeps my feet on the ground right now. And the moon in orbit.
You got it. It's all connected. But hold on, because you mentioned something even wilder. Relativity, right?
Yeah, that's where I usually start to lose it, to be honest. Space-time. Is that like a real fabric or something?
I like to think of it that way. Imagine like a trampoline. If you roll a marble on it, it goes straight. Now put a bowling ball in the middle, what happens?
The trampoline curves, right? Makes it dip where the bowling ball is.
Exactly. Roll that marble again, and its path curves around the bowling ball because of that dip. That's kind of how mass affects space-time. A big object like the sun, it makes a dent in space-time itself.
So Earth and the other planets, we're just following those curves.
That's the idea. Those curves are what we experience as gravity. It's not some force acting from far away, like Newton thought. It's built into the shape of space-time.
Whoa. Okay, that is a lot to wrap my head around. And this all comes from math.
Absolutely. Einstein used some seriously complex math, something called differential geometry, to develop relativity. And get this. His predictions, as wild as they were, they've been proven right again and again through observations.
So from triangles and circles, we're up to calculus and warp spacetime, all thanks to math. Our picture of the universe has changed so much.
And it's not over yet. Just wait till we get to how math helps us find other planets, maybe even life out there.
All right, let's talk aliens. Or, well, maybe not aliens exactly, but other planets that could have life.
You got it. We're diving into exoplanets. Those are planets orbiting other stars, and yep, math is the key to finding them, even figuring out if they could be livable.
That's what I'm talking about. But how do you find a planet light years away? It's not like we can see them directly, right?
You're right, it's not that easy, but we've got some math tricks up our sleeve. One way is to look for tiny wobbles in a star's movement.
Wobbles.
Yeah. If a planet's orbiting a star, its gravity tugs on it a little bit, makes it wobble.
Oh, like a tiny bit.
Super tiny. Way too small to see directly. But here's where the math comes in. We can use something called Doppler spectroscopy to find those teeny changes in the star's light.
Doppler. Oh,
Yeah.
okay, you'd have to explain that one.
Okay, so imagine an ambulance siren. Gets higher pitched coming towards you, lower going away, right?
Right.
Light waves, same idea. Star moves towards us a bit, light waves get squished, bluer, moves away, they stretch out, redder.
Okay.
So we analyze the starlight, and by looking for these tiny shifts, we can see that planet's gravity tugging away.
So we're like listening to the stars for wobbles. That's wild. But finding a planet is one thing. How do we know if it could actually have, life?
That's the big question. And yep, more math to the rescue. We use what we know about life here, right? Needs liquid water, good temperature, energy source. That gives us the habitable zone around a star.
So like Goldilocks. Not too hot, not too cold.
Exactly. And a star's size, its temperature, all that determines where that zone is. We use all that, plus how far away the planet is, and calculate if it fits in that sweet spot.
So even if we haven't met any aliens yet,
Not yet.
we're using math to figure out the best places to look.
Exactly. And the more we find out about these exoplanets, the better our math gets, so our search just keeps getting more accurate.
This is incredible. Started with triangles in the sky. Now we're searching for life on other planets. Math is the key to it all.
It really makes you think, Each equation, each calculation, it brings us closer to answering these huge questions we've had forever. Who knows what we'll find out there, just waiting for the right math to unlock it.
That's something to think about, listener, next time you look up at the night sky. The universe is a vast and mysterious place. But with the power of math, we're cracking the code, one equation at a time.